Hello everyone. In this video, we are going to be introducing the concept of matrices. We will start by defining what a matrix is. Here we have it. A matrix is a rectangular array of elements. Now, this word matrix is singular of matrices. Now, the elements here can be numbers, they can be letters, or a combination of both. For example, if A equals, let's say, A, B, C, D. Now we can see here that the uppercase here represents the matrix, while the lowercase element represents the entries or the elements within the matrix. This can be called elements or entries. So for example, C is an entry, A, B, D are also entries. Elements in matrices are arranged in rows and columns. So here is the first row, and here are the elements in the second row. So the rows can be obtained by just introducing an horizontal line. So we can see that A and B are elements in the first row, C and D are elements in the second row. Similarly, if I introduce a vertical line, we can see that A and C are elements in the first column, and B and D are elements in the second column. Therefore, I can write A as A11, A12, A21, and A22. A11 tells us that this element right here is in the first row and first column. A12 shows that this entry right here is in the first row and second column. A21 represents an element in the second row. This is the second row, but in the first column. And finally, A22 tells us that this element occupies the second row and the second column. So basically, this representation looks like this. Any entry A, the first subscript is going to be its position on the row, and the second is going to be its position on the column axis. So this is the representation. The number of rows and columns in a matrix gives it its name. For example, we can see here that this matrix has 2 rows and 2 columns. Therefore, this matrix is going to be called a 2 by 2 matrix. So naming a matrix requires us to obtain the number of rows and the number of columns it has. For example, if P is this matrix, A, B, C, D, E, F, G, H, I, J. Now we're going to see that there are 2 rows here. This is row 1 and this is row 2. Also, there is column 1 right here, column 2, column 3, column 4, and column 5. Therefore, this matrix P is a 2 by 5 matrix. So we are going to start with the row 2 by then the column. So this is a 2 by 5 matrix. So how do we think a 5 by 2 matrix is going to look like? That's also very easy. A 5 by 2 matrix is going to have 5 rows and 2 columns. So let's take a matrix Q that's 5 by 2. So we are going to need 5 rows. So that's going to be something like A, B, C, D, E, F, G, H, I, J. So I've got row 1 right here, row 2, row 3, row 4, and finally the 5th row. And also introducing a vertical slash. This is the first column and this is the second column. So I've got 5 by 2. Now this knowledge is going to be very useful in defining some very special matrices. The first one we are going to consider is a row matrix. A row matrix is a matrix that has all the elements on a single row. So for example, if I've got a matrix V, that's a row matrix, it's going to look like this. So let's have A, B, C, D. So we can see that all the 4 elements here are on a single row. The second one we would consider is a column matrix. Unlike V, which is a row matrix, if a matrix, say W, is a column matrix, then W is going to look like this: A, B, C. So we can see that all of the elements here are on a single column. There is also what we call a zero matrix. So a zero matrix is a matrix that has all of its elements to be 0. So if I've got a matrix, say B, that looks like this: 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is going to be called a zero matrix. We've also got square matrices. A square matrix. A square matrix is a matrix that has the same number of rows and columns. For example, matrix C that looks like this: A, B, C, D, is going to be called a square matrix because it has 2 rows and 2 columns. Also, this matrix A, B, C, D, E, F, G, H, I is also a square matrix because, as we can see, we've got 3 rows: the first row, second row, and third row. And we've also got 3 columns: the first column, the second one, and the third one. We also have another one, the identity matrix. An identity matrix is a matrix that has all of its elements to be 0 except the ones on the leading diagonal, which are 1. So all the elements are 0 except the elements on the leading diagonal, which have values of 1. So for example, in fact, most times we just represent the identity matrix with an I. So if I is an identity matrix, then all of the elements would be 0 except the ones on the leading diagonal. So I'm just going to erase this and replace them with 1. So this is called the leading diagonal, the diagonal that runs from the left to the right. Now we can see here that this matrix is 2 by 2. So this is the identity matrix for a 2 by 2 matrix. Now, how do we think the identity matrix for a 3 by 3 is going to look like? That's very easy. Just start with a 3 by 3 zero matrix, 0 rows, 0 column. Identify the leading diagonal. That's from the diagonal from left to right. So once you identify that, just erase the zeros and replace them with 1. So this is an identity matrix, a 3 by 3 identity matrix. We also have what's called the inverse matrix. The inverse matrix relates so much with the identity matrix. If A is a matrix, for example, then A raised to the power of -1 is going to be called its inverse of A. So whenever A is multiplied with A inverse, it's always going to give A inverse times the matrix, and we would always arrive at an identity matrix. So this is the relationship between a matrix, its inverse, and the identity matrix. A times A inverse would always give A inverse times A, which would give the identity matrix. And finally, we've got the transpose of a matrix. So for example, if we are considering matrix A, its transpose is going to be written as A raised to the power of T. And this is just changing the rows and the column of a matrix. What do I mean by changing the rows and column? Let's consider this 2 by 2 matrix. So it is evident that A and B are elements on the first row, C and D are elements on the second row. Similarly, A and C are in the first column, and B and D are in the second column. So the transpose of this matrix is just going to be AB, then C, D. So it's evident that the elements in the first row now occupy the first column, while the elements in the second row now occupy the second column. That's the transpose of a matrix. In the next video, we are going to be considering addition and subtraction of matrices. See you then. Thank you.